Hello, my name is Mr. Asprey, and this is my Edexcel IGCSE exam questions series 2, and this is number 27, area. Okay, we have a very funky looking area here, and we're told that the area of the whole shape is 434. Find the length of CD. Okay, so what I'm going to do is, because it's a compound shape, I'm going to split it up into two shapes. I'm going to call this one A and I'll call this one B. Now B is actually quite straightforward to calculate. It's just a rectangle, so it's just base times by height, or length times by width. Okay, so I can do that on my calculator, and that is 336. So that means the area of A is the total area minus this 336. Okay, so that's 434 minus the previous answer. So that's equal to 98. Okay. Now, what other lengths do we know? Well, actually, this blue line that I've drawn here, we actually know the length of that, because the whole thing down the bottom is 28. And we have these 5 and 5 either side here. So if I take two lots of 5 from 28, I get 18. So that width there is 18. Okay. And also we know what the height is of this trapezium, because we can see here that the overall height of the shape is 20 and the height of this side is 12. So the difference between them is 8. Okay, perfect. So we now know the area of that trapezium is 98, but we also know the area of a trapezium given in our formula sheet, should I say, is a half of the two parallel sides added together multiplied by the height, or the gap between them. Okay. So what do we know here? Well, the two parallel sides are x, the one we're trying to find, and 18, so this one across there. That needs to be divided by 2 and then multiplied by the gap between them, which is 8. Okay, so I can take my 98 and I can divide it by 8. That gives me 12.25. So 12.25 is now equal to x plus 18 over 2. I can then times it by 2, and that gives me 24.5, and that's now equal to x plus 18. And then I can subtract 18, and we've just solved that equation and found that x is 6.5. Beautiful. Okay, next question, and we've got semicircle and we've got the diameter. Okay, so if we know the diameter, it means we also know the radius, which is obviously half the diameter. Because it's a semicircle, that radius will be the same all the way around. So I can draw a straight line up, and that will also be 6. So that means I can get the area of the rectangle. Because the area of the rectangle is just going to be 12 is the base, times by 6 is the height. So that's 72 centimeters squared, of course. Now, the area of the semicircle, well, the semicircle it's a circle, which is pi r squared, but it's a semicircle, so it needs to be halved. So that's pi times by 6 squared over 2, and that will give me 36 pi on top, then halved, so 18 pi. So I'm just going to leave it like that in exact form. So the shaded area is equal to the rectangle minus the semicircle, which is going to be 72 minus 18 pi. So I can put that into my calculator to get the answer, which then I can round. So 18 pi, and that gives me 15.4 0.45, which again is approximately 15.5 when rounded to 3 significant figures. Perfect. Okay, we have a circle and we have a trapezium, and we're told that the height of the trapezium is h and the area of the circle is equal to the area of the trapezium. Right, that sounds to me like an equation because I see the word equal. So let's set up an equation then. So the circle area is pi times by r squared, and that's equal to the trapezium, which is the two parallel sides added together, divided by 2, multiplied by the gap between them, or the height in this case. Okay, fantastic. So I think, probably not is a good idea to just solve it straight away in your calculator. Maybe we need to put a little bit of working. So I will actually find out what this is in terms of pi. Yeah, so that's 289 over 4 pi. And then let's work out what this is when I add those two together and then divide by 2, and that is 22.5 times by h. And then we can do that h is equal to this divided by 22.5. And that's a good amount of working there shown. So let's just put that back into our calculator. Times by pi. And then if ever you want to do it all over something and you've forgotten to press the button, you can press a bracket like that and then just get rid of it. So that's over 22.5. And that gives you 10.1. Which is approximately 10.1. Okay, great. Again, that's a rounded value. Lovely. Okay, we've got two semicircles here. The inner semicircle has a radius of 7 and the path has a width of 2. So that means if I was to draw a line up to there, that would be 7. So it means that the line all the way to the top will be 9. Work out the perimeter of the path. Okay, well again, because the radius of the outer circle is 9, it means that this gap in here is 2, and this gap over here is also 2, so we're going to need to know that. So what I need to do now is just find the perimeter of the inner circle, so I'll do that first. So the formula for the circumference is equal to 2 pi r, but because it's a semicircle we're halving that, so that's just pi r, which in this case is just 7 times by pi, so 7 pi. Okay, and now let's find the green part, which again is a semicircle. So it's 2 pi r is the formula for circumference, but we need to half it. And then that's just pi r, so this is just 9 pi. Okay, brilliant. So the perimeter is equal to 7 pi plus 9 pi plus the 2 and the 2 at the end here. So that's a total of 16 pi plus 4. It asks us to give it to one decimal place, so I've already put that into my calculator. 16 times by pi and then plus 4 gives me approximately 54.27. It's to one decimal place, so approximately 54.3. Perfect. Okay, we've got another compound shape here, and we're told that the area of the shape is 91.8. Okay, so I'm just going to chop it like this to make a rectangle and a triangle. which I think is probably the easiest thing to do. Or is it? Yeah, we'll go with that. I think that's the most straightforward thing to do. Okay, so the height of this blue line that I've drawn must be 6. Because we've got 8 there, and add 6 must make the 14. Now we know this is x going across. So this distance in here is 13 without the x, so it's 13 minus x. Okay. So the overall area will be a plus b. So 91.8 will equal a, which is 14 times by x, because the width is x and the length is 14, and it's a rectangle, plus a half of the base of the triangle multiplied by the height, because that's the formula for a triangle, half base times height. So this is 14x, and here we're going to get a half times 13 times 6, which is the same as 13 times 3, which is 39. And here we're going to get a half times minus x times 6, which is the same as minus x times by 3, which is just minus 3x. So 91.8 is actually equal to 11x plus 39. So to solve this equation, we take 39 from 91.8, and that gives me 52.8 is equal to 11x, and then we divide through by 11, and we get 4.8. So x is equal to 4.8. Perfect. Okay, this question has tripped up so many people. I've seen this question before, and when I've given it to students on exams, invariably they get it wrong quite frequently. And that's mainly because it says they need to apply 2 coats of wood varnish to the front of the door. We know that 250 millilitres of varnish will cover 4 meters squared. So how many millimeters of wood varnish will Julie need? Okay, so first off we need to find this shaded area, which is obviously the rectangle minus the semicircle, because we don't need to paint the window. That would be a bad idea. So 2 times 0.75 is the rectangle, and then the semicircle is, well, the semicircle has a radius, which is important, of 0.25, half of the 0.5. So the area is pi times by radius squared, and it's a semicircle, so we have to divide by 2. Okay, so we can do that calculation. 2 times 0.75 minus pi multiplied by 0.25 squared over 2, and we get 1.4018. Now, because we need to do 2 coats, we're essentially doing 2 times the area. So I just double that because I need to paint it twice. So I need to paint this much area. I think that will do actually for accuracy. Okay, and that is meters squared. Okay. So we know that 250 milliliters of varnish is equivalent to 4 meters squared. So it'd be quite useful to find what 1 meter squared is. So let's take my 250 and divide it by 4. And that gives me 62.5 milliliters will cover 1 meter squared. So to do that, we just divided by 4 here. so using the unitary method, and then let's times it by 2.8 to get exactly what we want, which is 2.8 meters squared. So times it on the other side by 2.8 as well. Okay, and we get 175. Okay, so that is our final answer. Okay, we have a square and 4 semicircles, and basically the area of the square is 36. Okay, so 36. Well, that just means that each side is 6, because 6 times 6 is 36. Calculate the total area of the shape. Okay. Well, essentially, if we have 4 identical semicircles, then that's equivalent of having 2 full circles. So all I need to do to find the area of this shape is do the area of the square plus 2 full circles, which is pi times r squared. And the radius must be 3. If the whole thing is 6, then half of that is 3, basically. So 3 squared. Okay, I think that's it. So the question did look quite daunting to start with, but when broken down, it's relatively attainable. Saying that, I'll probably get this wrong now and have to re-record it. No, I think that's good. Okay, we've got one face of the wall, and it's a pentagon with exactly one line of symmetry. Okay, so that's helpful because it means that I can draw a line right down here, and it means I'll get a right angle like that because it has a line of symmetry. He's going to paint this face of the wall once. Risky. I mean, you're going to need 2 coats surely. But anyway, he has to buy all the paint that he needs to use. Okay, yeah, the paint in each tin he's going to buy will cover this amount. Okay, so basically at the end we're going to have to round up to find the actual number of tins, because it says the least number of tins he'll need to buy. So there will be some wastage, basically. Okay, so the area of this part is just 6 times 10, which is 60. Now we know, we have to use Pythagoras' theorem. Lovely. So this is 5, and that's 5, obviously because it's got a line of symmetry, so it's perfectly even on each side. So in order for me to find h, the height of the roof shape, I guess, we'd have to use Pythagoras' theorem. So we take the long side and we subtract one of the short sides to find the other short side. Okay, so that would be 7 squared minus 5 squared, and that will give me, let's go with 4.9, 4.90. Okay, right, so now we can find the area of the upper triangle. So I might as well just find the whole thing at once, because it's a half times by base, which is 10, because it goes all the way across, multiplied by the height, which is 4.9. Okay, so I could just take this 4.9 now and just multiply it by 10 and multiply it by a half. And that gives me 24.5. Okay, so the total area that is needed to be covered is 60 plus 24.5, which is 84.5. So how many tins will he need? Because each tin is going to be 16, so if I divide through by 16, that tells me how many tins I'll need. So add on the 60. Yep, Okay, divide it by 16. Okay, so I get 5.28, which rounds to 6 full tins. And that is because, you can't buy 0.28 of a tin, in for a penny, in for a pound. You're going to have to buy 6 tins here in order to cover everything. So 6 is the final answer. Okay, we've got 4 identical circles drawn inside a square. This looks like something out of a UKMT question. Each circle touches 2 other circles and 2 sides of the square. Yeah, okay, fine. The region inside the square that is outside of the circles, shown shaded in the diagram, has a total area of 40. Okay, right, so reading all of that is basically the only bit of information I really care about is that the shaded area is equal to 40 centimetres squared. Work out the perimeter of the square. Wowzer, that is actually quite tricky, isn't it? Okay, let's call one radius R, because then we can see that this would be R, this would be R, and this would be R. So the full height of this square would be 4R. And of course, because it's a square and this is perfectly symmetrical, the width would also be 4R as well. So we could say that we know that the shaded area is equal to the area of the square minus 4 of these circles. Yeah, that makes sense. So the shaded area is 40, as given in the question, and the square, well, is 4R times by 4R. Base times height, or length times width, minus 4 times the circle, which is, because we've just designated this as R, it's just pi R squared, isn't it? So pi times R squared. Okay, lovely. Oh, this is a question 20. How exciting. Okay, so 40 is equal to 16R squared, because 4R times 4R is 16R squared, minus 4 pi R squared. Okay, so in a situation like this, just as if what am I trying to say here? The purest way of doing this, rather than just working out the value of whatever 16 minus 4 pi is, we can actually factorize here. So it looks like this. So taking out an R squared, basically. And then we can divide through by that factor. And just this way, it's just a bit nicer and a bit neater. And it gives us an exact value as opposed to having to round and lose accuracy. So this means that R is the square root of 40 over 16 minus 4 pi. Okay, I mean, I've just said all that, and I'm going to find out what the value is anyway, because it does say to 3 significant figures. I don't know, maybe I've just got my A-level hat on here, where a lot of the time you have to give your answer as exact values, but not always the case at GCSE. Anyway, that's the value of R, which is 3.413. So what's the question actually asked? It's asked for the perimeter of the square. So the perimeter of the square would be all 4 sides, and each side is exactly the same. It's 4R. So that will be 16R, which is equal to 16 multiplied by 3.413, which is, just times that by 16 to get our final answer of 54.6. And I hope you enjoyed that, and if you did, please consider subscribing to the channel, and I will see you in the next video. Bye for now.